Welcome to Flyward. We are going to analyze a transaction from a maintenance forecast perspective in our maintenance forecasting system. The first screen we land on is the Fleet Summary tab, where the lease management system has fed our modeling tool with all the information required to run a maintenance forecasting analysis. Here, we will find all fleet assets uploaded in our system, but we will only use one asset to perform a walkthrough of our forecasting system. In the Fleet Summary, you have the ability to filter the list by asset type using the quick filters here or by the portfolio selection menu. You can also choose how many assets you want to see on a page and move between pages here. Now, let's proceed with our demo asset here and run the forecast. Having the asset selected and checked here, clicking the Fly button takes us to the Maintenance Forecasting tab, where we can see all the basic information about the asset in terms of its operator, the aircraft type, engine, and more. Here, we can select the date to which we will fly this asset for this forecast report. The default date that populates here is the redelivery date of this leased aircraft. We can pick a custom date using a date picker, before or after this date. But we will go back to the redelivery date here. The contract information is all set up here to run the analysis, but we can change some of the assumptions if we want. We can change the life-limited parts build standard or build goal. We can change the operating environment and the assumptions relating to the utilization of this aircraft, defining the assumed number of hours and cycles flown monthly going forward, which gives us the average flight hour to flight cycle ratio. We can make changes here, for example, the flight cycles. If we change that to 100 cycles, then the flight hour to flight cycle ratio changes accordingly. We also have additional parameters. Here we have the limits taken from the knowledge base and adjusted for the specific operating conditions these engines are in. Here we see the impact of the flight hour flight cycle ratio, the operating environment, and the derate percentage on the operational limits of the engine. Moving on, we have toggles to activate maintenance reserves and end-of-lease adjustments, along with the corresponding rates and funds for each component type, all extracted from the contract data. These can also be overwritten for developing custom scenarios or simulations tailored to your needs. For example, if you want to investigate the impact of starting or stopping the payment of maintenance reserves on the economics of the transaction, this is an easy way to do it. With a simple click on the Fly button in the top right section, we have an extensive maintenance cash flow report generated in a matter of seconds. We can see all of the assumptions discussed before, followed by a chart that highlights all the core components of what we're interested in, on an asset, aircraft, or engine level. Here we see our forecasted estimate of dollars maintenance burn for each month until lease maturity, which is how much utility is being burnt off the aircraft in dollar terms from the tech spec date going forward. We can then see the corresponding reserve balance if the lessee pays maintenance reserves, and then one minus the other gives us a shortfall figure, which is the equivalent of how much exposure the owner should expect from a potential credit event. If the airline were to give the aircraft back to the owner this month, just before this shop visit here in April 2027, we have close to $18 million of burn and $11 million worth of reserves, which opens up a $7 million potential economic shortfall. And then at the end of the lease, we also have an end-of-lease payment that covers some of that shortfall as well. We can filter this chart for each component and have a closer look at their cash flow as well. That is a very general overview of what should be happening during the lease, but we can look at it in a bit more detail with the event schedule, where we see the dips in burn corresponding to the event's timing. We can see the 12-year airframe check occurring in December 2027. Then, in May 2029, we have an Engine 2 performance restoration visit driven by the event interval and a corresponding replacement of some of the life-limited parts because of the build standard required by the lease contract. In June 2029, there is also a performance restoration event on the first engine. We could manually align the second engine's event with the first by moving it into the same month. Flyward would instantly recalculate the scenario, optimizing the maintenance timing and financial impact. For the purpose of this walkthrough, though, we'll keep the events as they are. Then, in September 2030, we have the APU being shopped for performance restoration. Then we have another airframe 6-year check in 2030. Below, we can see the data for the chart in a table. Firstly, we have a column of the maintenance reserve cash flow coming in. Each event has an associated downtime relating to each of the components. This is controlled by the system administrator. Downtime is an estimate of the time it takes for restoration work to be performed in the maintenance facility. After the event downtime is over, the maintenance reserves associated with the refreshed component are repaid to the operator, but with another delay, also set by the administrator. This is an estimate of the time it takes to process the invoice by the lessor. In this scenario, there is a 2-month downtime associated with the 6-year check and a 1-month delay in payment. The same logic applies to the 12-year check and the engine performance restoration, but the details around the timing are different. We can click on any one of those events and have a look at what happens in more detail. In this case, the engine performance restoration, the utilization limit was 39,500 hours since the last shop visit. We are just about to reach that level, and therefore, the system triggers a shop visit. It costs $6.6 million, according to the knowledge base set up by the admin and imported here. This is the cost input by the admin for the base year and is escalated according to the desired escalation rate. We have collected $5 million in maintenance reserves associated with that engine on the Performance Restoration Fund. Therefore, the lessee needs to pay the difference, highlighted here under the event shortfall. And then this particular life-limited part, the HPT rear shaft, is failing the build standard test because it has less than 150 cycles remaining, while the build standard being set at 6,000 cycles. That means we need to replace it. That cost almost $600,000. You can see the part that gets paid out of the collected reserves, and then the lessee covers the shortfall. Returning to the table view and moving further down, we can find the next scheduled event. In June 2029, there is another engine shop visit, but this time it is due to one of the life-limited parts reaching its limit. During this shop visit, another life-limited part is also replaced because of the build standard. Back into the main results table, each one of these columns can be broken down into the components as set up in the knowledge base. In the case of this aircraft, we see the 6-year check, the 12-year check, the engine performance restoration, life-limited parts, landing gear, and the APU. You can click on the individual life-limited parts to see how they behave. This provides us with a monthly output per individual component. We see the cash flow in and out. The highlighted dates show the month during which the event happens, and after a period, we see the payment going out. Combined, we get the maintenance reserves balance built up over time. We also see the dollar maintenance burn, which is an estimate of how much value is burnt off the aircraft as it is being utilized, and how it resets during an event and stays constant during downtime. We have the utilization and the units it is in. For APU, we see APU hours and flight hours for engine performance restoration. But if we expand and hover over the life-limited parts, that utilization is in flight cycles. Moving forward, we have the end-of-lease payment, which is the calculation of the up-Z or down-Z payment that is required at the end of the lease. The next one is the full life shortfall, which represents the economic gap from a full life value for each of the individual components, calculated on a monthly basis. It accounts for the utilization burn, as well as any cash held in the maintenance reserves or at the end of the lease. Last but not least, we have the lessor contribution, which reflects the lessor's financial contribution towards the first event of the analyzed transaction, as agreed between the counterparties. This is input on a component level as well, but we didn't include it in our scenario here. Now that we are happy with the analysis, we can save it as a report and export it. We name it and press Save. We can now go to the reports, and we can bring it back as a time-stamped bit of history. We can share it with the rest of our organization and beyond.